Hello everybody and welcome to Data Engineering Stuff. Today we're going to talk about the differences between row-based storage and columnar stores. As you might perhaps know, I like to start things in a more practical way than in a theoretic way. So we're going to talk first about a concrete data set and then about a concrete query which we want to handle with our storage. So with our row-based or our columnar-based storage. So you see here our data set. There is some kind of online or some kind of retail store. There's a timestamp. It's in milliseconds since 1970. And there's the revenue in euros and the visitors per day. So these are just sample data you can imagine from a store where there are visitors, they buy stuff and so on, and you want to know on which day how much was sold in these stores. So imagine you have this in your database, then you can imagine from an analytical standpoint that you have a query like that. So you want to have the average revenue per visitor for the Berlin store in timestamp X and timestamp Y. So this is something you would really expect an analytical data store to really answer quickly. So first, we will try to solve this with a regular relational database management system, so a more row-based system. So we want to find all the entries that relate to Berlin. So it's here, 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 and here. And we want them to be in a specific time frame. And we want to get these values. So we want to filter on this value, this values, this value, and this value. And we want to get these values here. So we have two filter criteria and we have two values which we actually want to retrieve. So now, how does a relational database system work? Its disk layout works like this. So all these entries are saved on the disk near to each other. So it's row-based. It's every entry with every value. So a whole selling process in our business case is stored in total, and then the next is stored. So you can imagine the system has to go through all the entries, and he nearly has to scan all the fields in there to get through the data and to find our sales in the Berlin store in the given time frame. So there's really no optimization, and yes, it's just quite a waste of resource. So here come the more analytical systems in, and one of the most popular systems at the moment is some kind like a data lake. And I think the most popular format in data lakes currently is the Parquet format. So how could that be stored in this kind of data lake? So you have 4 Parquet files. Parquet itself is a columnar format. So you see that now these here are attached to each other and these are attached to each other because they are stored on disk near to each other in each Parquet file. So this really, it's quite a more a faster approach, because we get to the first file. We can quickly scan over the keys here. We have combined the store location, like Berlin, and the timestamp together to one key. And the parquet file is always ordered by these keys, so we can quickly retrieve the related columns. And so we can do like range queries in these files and are really, really fast with this. But what we have to do is we have to go through all the files. We check in the file if there is a related key. For example, in file number 4, there is no Berlin in there. So we have to open the file, we have to look in there, and then we see, oh, there's not related data. This gets worse if you get more files. And yes, it's more efficient than the relational database, because you see we had to access 4 files, but we only accessed 3 entries. We didn't have to read all the rows. We could quickly go to the relevant keys, but we have to look in each file to get it working. So now comes the best matching store, and this is a columnar store like Apache HBase. So how does Apache HBase work? It basically splits the data set by the key. We also have this, we have the same combined key as we have in the parquet files. So we have the store location and the timestamp, and we have these ranges which are managed by Apache HBase. It automatically assigned the range in the right size. It compacts files. It does a lot of optimizations, and we can directly go to the correct range because Apache HBase handled this for us. So Apache HBase knows that Berlin will never be found here and never be found here. So we'll only look into range 1, and in there the keys are ordered, so it will quickly find our related dataset or the dataset we want to find here, and also jump quite to these entries here, so we can easily calculate our task, which again was, I will show you again, show me everything from the Berlin store, timestamp X and Y, and yes, calculate the average revenue per visitor, which you can easily do if we just kept these 6 values out here. So that's the basic difference between a row-based store and a columnar store. A row-based store, you can easily access a whole object, I would say, so a whole row by its key, but you're really slow in making range queries and have then just get just individual fields. So in Apache HBase, you could say this here is something like a column family, and you could have another column family which is stored together. So we can highly optimize that. And in addition, there are much more optimizations that Apache HBase or other columnar stores can do. For example, they use some kind of Bloom filters. It's like a probabilistic approach to checking in which set, so in which range a given key might occur or not. They have a really intelligent way of buffering stuff for writes, for reads, for individual pages. They are highly parallelizable and scalable, much better than a relational database. They have these column families I already told about. And yes, they automatically resize ranges. So if you have, like, for example, many data sets for the Berlin store and only a few for the Bangkok store, it would make the Apache HBase system would create many ranges for the Berlin store. So it will distribute the data very intelligently. And yes, you will get a really high performance with the columnar store for queries that specifically match the keys you chose. So if you have queries that want to filter by the store location and the time. If you have this kind of queries, it will answer them really fast. But if you want to, for example, filter here, you will have a bad time. So that's the main feature of columnar stores. They have this one key, and they are blazingly fast in retrieving range requests on these keys. So if you have specialized use cases that need this kind of queries and need to answer them really fast, a columnar store is what you want. But keep in mind, for other workloads, columnar stores could be really bad. You could like to use a Parquet file style data lake for it because it's much more flexible. Or you could just go with a relational database system. So always keep in mind your use case. And if you know your use case, you know how often specific queries are needed, how important they are. So perhaps there's some complex query that takes like forever, but it's only needed once a month. You won't set up a columnar store for it. You will do this for queries that have a high frequency, that are difficult to handle by row-based storage, and then you would go with a columnar store. So I hope this helps with choosing the right storage for your data. Think about columnar stores. Keep in mind that they are really specific for specific use cases, and then I think you're good to go. Thank you and goodbye.